Hello, my name is Alex Deal, and this is Project 4 Selected Topics for my team, including me, Pranav Nathan, and Harry Crocker. The first topic I want to talk about is generative design. This is something I'm really passionate about because I use it quite often nowadays, and I think it has real potential in the future. It's an algorithmic and artificial optimization of designs and a tool that engineers can use in order to make fast and quick prototypes with really low amounts of mass and high strength ratios for specific applications. It could be a weapon, but it can also be an asset for us, as I can see it taking jobs away, but also bringing in a higher level of skill for those who really understand how it works. The industries that's really important for are automotive, aerospace, and healthcare. Generative design has many capabilities, including fast, efficient design exploration and promotes sustainability in that same regard. It encourages innovation with complex and efficient designs, including the ones you see here, which are actually some of my own. They're replacement swan neck arms from an original design which was high in mass and had some trouble in the buckling department. However, using generative design, I'm able to see complex solutions, in this case somewhat minute, but still very generally variate in terms of width and length that otherwise would be hard to design on your own. The limitations are it's not ideal for large scale production due to the slow build times and high costs, and it's computationally dependent on the computers that you have and the software you're able to run. But the overall process integrates well with the growing 3D printing market and ensures complex and efficient solutions for the future. The next thing I want to talk about is IoT, Internet of Things and Industrial Internet of Things. IoT connects devices for data sharing and applies a multitude of facets for complex analysis of our production sites as they are today. It's the next step in terms of making Industry 4.0 all that more beneficial to the consumers and producers who utilize this technology. It allows predictive maintenance in manufacturing and real-time equipment monitoring through the use of these devices. The benefits of IoT are magnitudes larger than what they ever could have been in before. In the past, you'd have to have somebody on the floor always watching, making sure things aren't going wrong. With IoT, you can leverage decision-making skills with real-time data and enable automated processes for quality control, even real-time monitoring and predictive analysis for the repair, replacement, or even the swap of entire assembly lines or products, depending on market share, value, and even runtime. The challenges of IoT are that they encompass high input costs, cybersecurity risks, and reliance on stable connectivity, which in some parts of the world is still not an option. However, as things ramp up, I think that implementation can come with a lower cost as unlike it is right now. And especially for smaller organizations, they'll be able to see this and take advantage of it in the future. The last thing I want to talk about is the Kano model. The Kano model is something that allows you to gauge customer satisfaction within the framework of key features such as basic performance and excitement. Interesting part of the Kano model is I actually had the chance to hear about him as he was doing a lecture in Japan. The applications for the Kano model are really in any industry where you have a product that has some sort of development and you want to have some feedback. It helps identify those features that enhance customer delight and therefore product and overall customer satisfaction. The importance of the Kano model is that it balances essential and innovative aspects of design. This can be anything from changing how things look, how a fad has changed the design's appearance to the public, and even the most minute details can sometimes be affected or indicative in the Kano model itself. It helps streamline the development process by prioritizing high-value features and ensure that product designs align with customer needs. The limitations are that the Kano model can be susceptible to bias and shifts over time and may fall out of favor in a specific mindset. However, the Kano model is different in that it should always represent the true values of the customers. And in that sense, it is oftentimes the job of the users of the Kano model to understand how the Kano model is changing in terms of what it's grasping and what it's prioritizing. And this way, you can make sure that you understand the Kano model and apply it correctly.
Next, let's take a look at lean manufacturing. The goal of lean manufacturing is to eliminate waste in order to improve efficiency and deliver customer value. This is a very important topic because it allows you to create manufacturing processes that don't have waste. And it follows these 5 lean principles that you can see on the right. The first one is to define value. It's important to understand what value means in your manufacturing process so that when you optimize for what value means to you. Then, you can map the value stream before moving on to creating flow, establishing pull systems, and pursuing perfection. Some core tools are 5S, Kanban, and Kaizen for a streamlined workflow. And in total, lean manufacturing can enhance quality, reduce costs, and minimize production time. Augmented reality is another very powerful tool that can be used to improve manufacturing processes. Augmented reality enhances manufacturing processes by overlaying digital information on real-world environments. As you can see on the right, this is an example of how AR can be used in manufacturing. This engineer is taking a look at a robotic arm and is able to see the overall performance and the efficiency, temperature, and humidity that are affecting the performance of this robot. This can be incredibly powerful so that the engineer can make better decisions than if he was just looking at the robot with his bare eyes. Augmented reality can be used for assembly guidance, maintenance instruction, and error reduction. It speeds up prototyping by visualizing designs in real time, and it can improve training with interactive simulations for complex equipment. Some examples of devices that are using augmented reality are AR glasses, such as Microsoft's HoloLens. In addition, there are mobile applications that can take advantage of the camera on a phone in order to project information into the user's field of view. Next, we can analyze fault tree analysis. Fault tree analysis is when you identify the root causes of system failures using a top-down approach. As you can see in the image below, the system failure is put at the top, and we can look at all the potential things that can cause the system failure. As you can see, you can break down system failure into 2 potential areas, equipment failure or operator area, which you can further break down. We can take a look specifically at equipment failure. Equipment failure can be either mechanical or electrical, and when it comes to mechanical failure, you could see substandard material quality and mechanical wear and tear due to lack of maintenance, leading to this mechanical failure. By going down this top-down approach, you can therefore focus on the root causes of a system failure. That way, all of these failures can be less abstract and more focused. This is essential for assessing risks in complex manufacturing systems. When you have hundreds of robots manufacturing many components, it's important to be able to break down your risks. It also helps prevent costly downtime and ensures your product reliability. You're very often going to see these types of fault tree analyses in aerospace, automotive, and high-tech industries, and they rely on accurate data and structured analysis to produce effective results. Next up, let's look at product benchmarking. Product benchmarking is when you're comparing the product performance, cost, and features of your product versus competitor products. For example, you can see on this diagram to the right that you can compare the product that you're making against a couple of competitors. And then you can compare it in specific areas, such as product quality, pricing, promotion, reputation, and partnerships. By looking at the performance of your product versus other competitors' products, you're able to get a much better idea of how your product might fare in the market. And so this way, you can analyze it much more detailedly and get much better results. This allows us to identify gaps to improve quality and manufacturing efficiency. This will drive innovation by studying the industry leaders' best practices. Because if you look at your competitors and you're not only looking at your own product, you can get a much better and broader view of how this product compares to others. In addition, it'll focus on metrics like production speed, defect rates, and cost effectiveness. By looking at these quantitative factors, you can get a much better idea of how your product fares. And this system is often used extensively in automotive and consumer goods industries.
The next topic is iPhone 16 DFX. The iPhone 16 incorporates advanced ergonomic design to improve user comfort and interaction. Its newest feature is this camera control button, which gives a much more intuitive and designed for human factors experience. Some of the key ergonomic features include rounded edges and a lightweight body for a natural grip, minimizing hand fatigue during prolonged use. It also has an optimized screen size and display size to reduce eye strain even in low light conditions. It also has intuitive button and port placement for seamless accessibility. Human factors principles prioritize inclusivity, ensuring the device accommodates diverse hand sizes and usage needs. This is a very versatile device. By focusing on these areas, Apple continues to be a leader in integrating functionality with user-centered design. The iPhone 16 offers enhanced accessibility, comfort in long sessions, and is great for professional use. This is an extremely versatile product that can be used by all sorts of users, and this is what makes Apple so successful, is that this is a product that can be used by anyone, and is super intuitive and very well designed for human factors. Some of the limitations are cost implications, as when you design for form, that sometimes drives up price. There are also some design trade-offs, where balancing aesthetics with functionality may not meet all of the user's preferences. There's also the trade-off between durability versus a lightweight design. It's important for these to be robust products, but they still need to be light enough for a user to comfortably hold in their hand. The next topic is minimum viable product. An MVP is the simplest version of a product that can be launched to test key functionalities and gather user feedback. Its purpose is to validate ideas with minimal resource investment, to identify customer needs and refine features based on real-world use. MVP is widely used in software, electronics, and manufacturing industries. One case study is Dropbox, who released an early MVP which was only a video demonstration to help communicate what the concept was. This garnered over 75,000 signups in 24 hours, validating strong market demand. Some of the benefits of MVP are its cost efficiency, as it reduces waste by testing ideas before scaling production. It's also a much faster time to market. It also is a user-centered design, which this is a big step in the customer discovery process of coming up with an idea. This is another application of where rapid prototyping technologies such as 3D printing are super helpful. Some of the challenges are that it may give underwhelming first impressions, as this is not the final product. It's also tough to balance functionality with aesthetics when designing this minimum viable product. And also the risk of feature creep. By overloading the MVP with too many features can dilute its purpose. Lights Out factories are fully automated facilities requiring minimal human intervention, capable of operating 24/7 without breaks. These factories rely on robotics, where machines handle assembly, quality checks, and packaging. They also rely on sensors and Internet of Things. Constantly monitoring ensures optimal operation. And AI systems, where intelligent algorithms make real-time adjustments to maintain efficiency. One example is Fanuc, a robotics manufacturer who operates Lights Out factory produce its own industrial robots. The capabilities of lights out factories are the productivity, which is greatly improved and increases the output. They're also highly precise, as these are robots that are very consistent and high quality. They also save a lot of money as they reduce labor costs and there's low energy usage since the lights are turned off. Some of the challenges are that there's a high initial capital investment to set up this infrastructure. There are also maintenance needs. These robots cannot run forever, and they do need to be repaired every now and then. There's also limited availability as current systems struggle with small batch custom production. Despite challenges, lights out factories are a crucial trend in achieving Industry 4.0 goals. Here are the resources we used for this project. Thank you for listening, and I hope you enjoyed learning about these selected topics.